Okay, let's do an example in which we will turn a normal random variable to standard normal random variable and use probabilities of that normal random variable using the table for z. Okay, we have a random variable which is normal. This is a very key point. It is normal, and then its mean is given, it is 20, and its standard deviation is given 5. Use those information to find the probabilities given in terms of y. Remember that we have only one table. That's for table for z, the standard normal random variable. So we have to turn the normal random variable, the given normal random variable, to the standard normal random variable. But what was the fact? Remember, recall that for any normal random variable such as y, if we subtract the mean of that normal random variable from y and then divide it by sigma, what we will find is the standard normal random variable. So this is the key point here for us. Mu, which is mean, is 20. Sigma, here the standard deviation is 5. So wherever we can generate y minus 5 over, sorry, y minus 20 over 5, we can replace it by z and then go ahead and use the table. Okay, let's see how we apply this thing for this probability of y less than 27. What is the probability of that? Remember, we are trying to generate y minus 20 divided by 5. So I will always start with minus mu of both sides. So minus 20 of both sides. It will give me probability of y minus 20 is going to be less than 27 minus 20. Then we have to divide it by 5. So we get probability of y minus 20, and everything's happening inside probability, not outside. We are not multiplying the whole probability, we are multiplying inside of the probability, the inequality we have, to by 5. Okay, 27 minus 20 over 5. And when you get to this step, you see that now I can apply the fact that we just mentioned up there. Wherever you see y minus z over 5, you can replace it by z. And then this is 27 minus 27 over 5, 7 over 5. And if you divide that, you will get what? 1.4, and that's 1.4. So now we turn y probability to z probability, and when you have z probability, right away we have the table. Now let me import the table here. We go ahead, import the table, and it's here. And then look for z less than 1.7, 1.4. 1.4 is a positive value, and it is z less than k. So here's k is 1.4, so it will be 1.4 and 0, 0. So this is 1.4, 0, 0, and then you do this thing, you get the number you see there. So that is 0.9192. 0.9192 is the probability of z being less than 1.4, but we already showed that this is the same thing as probability of y being less than 27. How about the second one? The second one asks for probability of 9 bigger than y. Sorry, y bigger than 9. Okay, so y is normal. We have to generate y minus 20 over 5 minus 20 both sides. So 9 minus 20 less than y minus 20. Then divide both sides by 5. So probability of 9 minus 20 over 5 less than y minus 20 over 5. And then when you get there, this guy here is z. So z is going to be bigger than 9 minus 20 is minus 11 over 5. So this is negative 2.1. So we are looking for negative 2.1. Probability of z being bigger than negative 2.1. This is a negative k, and while you remember, you can always drop the negative sign, but you have to flip the inequality. In other words, we are looking for probability of z less than 2.1, and 2.1 we can find it from this table. Let me just do it. 2.1 and then 0 0 comes down here. That is 0.9821. So that is 0.9821. Well, when you turn it to the z value, from that point on, everything is as we learned in the section 4.2. Okay, and the last one, let me do the last one now, the third one, probability of y less than, bigger than 12, less than 23, and we want to find that probability. Okay. So let me zoom in a little bit more, sorry. Okay, and I will bring this down to be able to use it. Okay, so we have everything in terms of y, we have to turn it to z, but we always remember y minus 20. Now we have two inequalities and three sides. You have to subtract all three sides, negative 20 from all three sides. So 12 minus 20 is less than y minus 20, and 23 minus 20. And this is, then we need to divide all three sides. See, the key is here. We want to generate y minus 20 over 5, and we do all these steps for all three sides to generate y minus 20 over 5. So now we divide all sides by 5. And you see that the middle part here, this guy is z, this guy is negative 8, negative 8 over 5. That gives me negative 1.6, so negative 1.6. And the right hand side is 3 over 5, and that's 0.6. Okay, this is the key step. We turned y probabilities defined by y to probabilities defined by z. Now from this point on, we have to make sure that we turn this to values like probability of z less than k and read it from the table. And this, you remember from the previous section, we can write probability of z less than the bigger value minus probability of z less than the smaller value. Okay, but there is a negative sign there, so we have to make sure that we deal with that at this stage. So you can always drop the negative sign, but you need to switch or flip the inequality. That's nice. Then probability of z less than 0.6 is there. Now the next step is that if you have z bigger than, turn it to z less than. How do we do that? 1 minus probability of z less than 1.6. First get rid of negative sign, then flip greater than to smaller than. Okay, so now these both the probabilities we have, z probabilities, we can find it from the table. Let me bring down the table here, and I have z less than 0 0.6. 0 0.6 is here, and that gives me 75.75 57, and 1 minus probability of 1.6, it is here, 1.6 is here, 0 0 is there, so the probability we are looking for is here, so 0 0.9452. Well, these are just now the values we have to compute. Another way of doing that is that we add, so this minus goes in and turns this to plus. You add these two, 9, 0 goes 1, 0, and then these two, 16, 17, and 1.1 minus 1. This is 0 0.7009. So from this step on are what we learned before, but the final number we got is also equal to probability y, probability that we were looking for. This number is probability of y being between those two numbers, 23 and what was it, 12, and this is equal to 0 0.7009. So you will see this more and more often, that well, to find probabilities defined by a normal random variable, we turn it to first to z, the standard normal random variable, by doing this trick. Y minus mu over sigma is the standard normal random variable. Then use the table, find the probabilities, and that's what we are looking for.